Hi, my name is Cyril Pashon, BSBA MIS, and this is my course project for Data Communications and Networking 4. I will be discussing about point-to-point connections, branch connections, access control lists. A point-to-point connections is a private data connection securely connecting two or more locations for private data services. A point-to-point connections is a closed network data transport service which does not traverse the public internet and is inherently secure with no data encryption needed. Point-to-point connections are available in a range of bandwidth speeds including point-to-point DI, point-to-point Ethernet, or point-to-point PS3. A point-to-point connections provides unparalleled quality of service as it is not a shared service and follows the same direct path every time. Point-to-point links are used by businesses to provide reliable, secure point-to-point network data service for applications including credit card processing, file sharing, data backup, point-to-point VoIP, and video conferencing. A point-to-point network can also be configured to carry voice, video, internet, and data services together over the same point-to-point connection. Point-to-point circuits are also known as point-to-point link, private line, leased line, or data line. It is also one of the most common types of WAN connections, especially in a long-distance communication. Branch connections. Under branch connections are remote access connections, PPOE, VPNs, GRE, and eBGP. Remote access connections. Broadband connections. The cable system uses a coaxial cable that carries radio frequency signals across the network. A hidden CMTS communications with CMs located in the subscriber homes. The HFC network is a mixed optical coaxial network in which optical fiber replaces the lower bandwidth coaxial cable. A digital subscriber line is a means of providing high-speed connections over installed copper wires. The two important components are the DSL transceiver and the DSL-AM. Broadband connections. The advantages that DSL has over cable technology is that DSL is not a shared medium. Each user has a separate direct connection to DSL-AM. Development in broadband wireless technology are increasing wireless availability through three main technologies. Municipal Wi-Fi. Most municipal wireless networks use a mesh of interconnected access points. Each access point is in range and can communicate with at least two other access points. The mesh blankets a particular area with radio signals. The advantages that DSL has over cable technology is that DSL is not a shared medium. Each user has a separate direct connection to DSL-AM. Development in broadband wireless technology are increasing wireless availability through three main technologies. Municipal Wi-Fi. Most municipal wireless networks use a mesh of interconnected access points. Of each point is in a range can communicate with at least two other access points. The mesh blankets are particular with aerial radio signals. Cellular mobile phones use radio waves to communicate through nearby cell towers. Cellular mobile broadband access consists of various standards. Satellite internet services are used in locations where land-based internet access is not available, or for temporary installations that are mobile internet access using satellites as available network. Each broadband solution had advantages and disadvantages. Some factors to consider in making a decision includes cable. Bandwidth is shared with many users. Upstream data rates are often slow during high usage hours in areas with oversubscription. DSL. Limited bandwidth that is distance sensitive. Upstream rate is proportionally quite small compared to downstream rate. Fiber to the home requires fiber installation directly to the home. Cellular mobile coverage is often an issue even within the SOHO or where bandwidth is relatively limited. Wi-Fi mesh. Most municipalities do not have a mesh network deployed. If it is available and the SOHO is in range, then it is a viable option. Satellite is expensive. Limited capacity per subscriber often provides access where no other access is possible. PPOE overview. PPP can be used on all serial links including those links created with dial-up analog and ISDN modems. PPP supports the availability to assign IP address to remote ends of a PPP link. PPP supports CHAP authentication. Ethernet links do not natively support PPP. PPP over Ethernet provides a solution to this problem. PPOE creates a PPP tunnel over Ethernet connection. Implement PPPoE. PPPoE configuration. The dialer interface is created using the interface dialer number command. The PPP check configuration usually defines one-way authentication, therefore the ISP authenticated the customer. The physical Ethernet interface that connects the DSL modem is enabled with the command PPOE enable. The dialer interface is linked to the Ethernet interface with the dialer pool and PPOE client commands using the same number. The maximum transmission unit should be set down to 1492 versus the default of 1500 to accommodate the PPOE headers. PPOE verification. The show IP interface brief command is issued to verify the IPv4 address automatically assigned to the dialer interface by the ISP router. The show interface dialer commence verifies the MTU and the PPP encapsulation configure on the dialer interface. The show PPOE session command is used to display information about currently active PPOE sessions. The Ethernet MAC address can be verified by using the show interfaces command on each router. PPOE troubleshooting. Verify PPP negotiation using the debug PPP negotiation command. Examine the output of the debug PPP negotiation command. PPPoE supports an MTU of only 1492 bytes in order to accommodate the additional 8-byte PPOE header. The IPTCP adjust MSS mass segment size interface command adjusts the MSS value during the TCP three-way handshake. Fundamentals of VPNs. Organizations use VPNs to create an end-to-end private network connection over third-party networks such as Internet. Today, a secure implementation of VPN with encryption, such as IPsec VPNs, is what is usually meant by virtual private networking. To implement VPNs, a VPN gateway is necessary. The VPN gateway could be a router, a firewall, or a Cisco Adaptive Security appliance. Types of VPNs. Site-to-site VPNs connect entire networks to each other. For example, they can connect a branch office network to a company headquarters network. Remote access VPNs are used to connect individual hosts that must access their company network securely over the internet. DMVPN, or Dynamic Multipoint VPN, is a Cisco software solution for building multiple VPNs in an easy, dynamic, and scalable manner. GRE, or Generic Routing Encapsulation, is designed to manage the transportation of multi-protocol of IP multicast traffic between two or more sites that may only have one connectivity. There are 5 steps in configuring the GRE tunnel. Create a tunnel interface using the interface tunnel number command. Configure an IP address for the tunnel interface. This is normally a private IP address. Specify the tunnel source of IP address. Specify the tunnel destination of IP address. Specify GRE tunnel mode as the tunnel interface mode. Verify GRE. To determine whether the tunnel interface is up or down, use the shop IP interface brief command. To verify the state of a GRE tunnel, use the show interface tunnel command. Verify that an OSPF adjacency had been established over the tunnel interface using the show IP OSPF neighbor command. Troubleshoot GRE. Use the shop IP interface brief command on both routers to verify that the tunnel interface is up and configured with the correct IP address for the physical interface and the tunnel interface. Use the shop IP OSPF neighbor command to verify neighbor adjacency. Use shop IP route to verify that networks are being passed between the two routers. BGP. IGP and EGP, or interior gateway protocols, are used to exchange routers information within a company network or an autonomous system. Exterior gateway protocols are used for the exchange of routing information between autonomous systems. EIGP and IEGP, or the external BGP, is a routing protocol used between routers in different autonomous systems. Internal BGP is a routing protocol used between routers in the same SAS. BGP design considerations. When they use BGP, the use of BGP is most appropriate when SAS has connections to multiple autonomous systems. BGP should not be used when at least one of the following conditions exist. There is a single connection to the internet or another AS. This is known as single home. When there is a limited understanding of BGP. BGP options. There are three common ways an organization can choose to implement BGP in a multi-homed environment. Default route only. This is the simplest method to implement BGP. However, because the company only receives a default route from both ISPs, suboptimal routing may occur. Default route and ISP routers. This option allows Company A to forward traffic to the appropriate ISP for networks advertised by the ISP. All internet routes. Because Company A receives all internet routes from both ISPs, Company A can determine which IPs to use as the best path to forward traffic or any network. Although this solves the issue of suboptimal routing, the Company A's BGP router must contain all internet routes. BGP branch configuration. There are 3 steps to implement eBGP. Enable BGP routing, configure BGP neighbor, and advertise network originating from this AS. And access control list. An access control list contains rules that grant or deny access to certain digital environments. ACLs are a network filter utilized by routers and some switches to permit and restrict data flows into and out of network interfaces. When an ACL is configured on an interface, the network device analyzes data passing through the interface, compares it to the criteria described in the ACL, and either permits the data flow or prohibits it. There are 2 types of ACLs. File system ACLs filter access to files and or directories. File system ACLs can tell operating system which users can access the system and what privileges the users are allowed. Networking ACLs. Filtering access to the network. Networking ACLs tell routers and switches which type of traffic can access the network and which activity is allowed. Originally, ACLs were the only way to achieve firewall protection. Today, there are many types of firewalls and alternatives to ACLs. However, organizations continue to use ACLs in conjunction with technologies like virtual private networks that specify which traffic should be encrypted and transferred through VPN tunnel. Reasons to use an ACL. Traffic flow control. Restricted network traffic for better network performance. A level of security for network access specifying which areas of the server network service can be accessed by a user. Granular monitoring of the traffic existing and entering the system. How ACL works. A file system ACL is a table that informs a computer operating system of the access privileges a user has to a system object, including a single file or a file directory. Each object has a security property that connects to its access control list. The list has an entry for every user with access rights to the system. Typical privileges include the right to read a single file in a directory, to execute the file, or to write to the file or files. Operating systems that use an ACL include, for example, Microsoft Windows and 2000, Novels NetWare, Digital's OpenVNS, and Unix-based systems. When a user requests an object in an ACL-based security model, the operating system studies the ACL for a relevant entry and sees whether the requested operation is permissible. Networking ACLs are installed in routers or switches where they act as traffic filters. Each networking ACL contains predefined rules that control which packets or routing updates are allowed or denied access to a network. Routers and switches with ACLs work like packet filters that transfer or deny packets based on filtering criteria. As a layer 3 device, a packet filtering router uses rules to seize if traffic should be permitted or denied access. It decides this based on source and destination OP addresses, destination port and source port, and the official procedure of the packet. ACL best practices. ACLs everywhere. ACLs are enforced on each interface in nearly all security or routing gear. This is fitting as you can't have the same rules for outward facing interfaces and interfaces that form your campus network. However, interfaces are similar and you don't want some protected by ACLs and some exposed. The practice of an ACL on all interfaces is essential for inbound ACLs, specifically the rules that decide which address can transfer data into your network. Those are the rules that make a considerable difference. ACLs in order. In almost all cases, the engine enforcing the ACL begins at the top and moves down to the list. This has implications for working out what an ACL will do with a specific data stream. One reason organizations adopt ACLs is that they have a lower computational overhead that stateful firewalls and that they work at high speeds. This is essential when you try to implement security for fast network interfaces. However, the longer the packet remains in the system, while it is examined against the rules in the ACL, the slower the performance. The trick is to put the rules that you expect will be triggered at the top of the ACL. Work from the general to specific while ensuring the rules are logically grouped. You should know that each packet will be acted on by the initial rule that it triggers. You could end up passing a packet via one rule when you intend to plop it via another. Why do we use access control lists? There are a variety of reasons we use ACLs. The primary reason is to provide a basic level of security for the network. ACLs are not as complex as in-depth protection as stateful firewalls, but they do provide protection on higher speed interfaces where line rate speeds is important and firewalls may be restrictive. ACLs are also used to restrict updates for routing from network. Thank you.